Hello, welcome to GCP Online Meetup number 16. I'm your host, Jonathan Cham, and I am joined by the lovely Deanna Rowe. Deanna, how is the Windy City today?
Well, it's not that windy, surprisingly.
Really?
Hello, everyone. I'm Deanna Rowe. I'm a customer engineer in Chicago, obviously. Today, we will be talking about the weather in Chicago primarily.
Yes, weather. That's
No,
great.
just kidding. We're going to be focused on Ingress controllers for container engine and specifically for Kubernetes.
That's fantastic. I don't think there's anything more exciting on a Tuesday than to be talking about Ingress controllers, and nothing more exciting than having our own Drew Hoden tell us about them. So, Drew, how are you doing today, Drew?
Doing good. Not quite as windy in New York City either.
Well, hey, Drew, thanks for being here. I mean,
Sure.
one thing people don't know about you, Drew, is, Drew knows a lot about climbing Mount Everest, and I think the only thing left is actually doing it, right, Drew?
That's right. That's right. It's a
Yeah.
good Photoshop job.
Hey, I think you would look great up there on Mount Everest. So let's talk about Ingress controllers. Hot topic, a lot of questions around Ingress controllers, and I hate to say it, but the documentation is not great around Ingress, and I think just because there's so many variables and just so many knobs to turn when it comes to Ingress controllers. So, yeah, let's get started. Tell us about what Ingress controllers are, and let's get right into it.
All right. No, you're absolutely right, Jonathan. I think my first experience with Ingress controllers was probably similar to a lot of folks in that, hey, I was trying to solve this problem in Kubernetes around load balancing or deploying multiple services, and I was told Ingress controller or Ingress was the way to go, and it wasn't clear where to go from there, how to implement it. And so really, I think the answer was diving in deep and playing with the code that was there. Hopefully, this is going to be a great shortcut for all of you listening in, whether or not you've used an Ingress before. This will be a shortcut to getting a lot of value, and using Ingress in your applications is a really cool solution for load balancing. So the challenge that Ingress and Ingress controllers solve in the Kubernetes world and in the Google Container Engine world is, how do I load balance amongst many services in a large cluster? When I deploy a variety of microservices, if they're talking to each other within the cluster, that's handled just fine by Kubernetes. But as you know, if you want to send services to the outside world, typically we would use the service construct. That doesn't scale, or sometimes that's harder to manage if you're exposing in the tens or hundreds of services using kind of a dumb layer 4 load balancer, as you may have in, say, the Google Cloud environment. So the problem is, how do I have many services that are load balanced? How do I do more advanced load balancing with URLs, virtual hosts, kind of if I've been previously doing load balancing on NGINX or using proxying, et cetera. How do I do that in the Kubernetes world? And additionally, if I'm interested in using the Google Cloud Layer 7 load balancer, how do I program that automatically from within Kubernetes and my manifests? So these are some of the challenges that I think, if you've come across and have been told Ingress is the way to go, this is probably something you've heard. The last question is then load balancing internal services. Once you kind of go to the URL and virtual host-based routing, how do I do that internally as well? And we'll talk about that towards the end.
Right, and just like a real quick, 10-second overview. I mean, Kubernetes networking, all containers can communicate with each other, without a NAT, and they all have kind of some internal IP. So all containers and nodes can talk to each other, but when it comes to kind of exposing these containers or nodes to an external public-facing IP, that's when you have to, throw in things like the services and Ingress, right?
Exactly. So when you first deploy a pod, you've probably deployed in stages. First, you deploy a pod into Kubernetes. Ideally, you're actually using, say, a replica set where you say, I want between 1 and 5 of this type of pod. And you can log into the pods. But once you want someone from outside the cluster to access your service, which at the end of the day, you need to use something like a service. And I'll show you kind of what that looks like. The problem that we solve with Ingress is I've got a lot of traffic as we scale out this Kubernetes cluster and scale out our microservices. I got a lot of traffic coming at the cluster from external facing clients. How do I handle all this traffic, and how do I intelligently and quickly route it without having to deploy a ton of, say, layer 4 load balancers in the Google Cloud world? Yeah. So
That is the best orchestrated airport I've ever seen. There's
yeah.
like
So this is a great
500 airplanes.
it's a time lapse photo, but you get the idea, right? You need
Yeah.
something that intelligently takes this traffic and routes it to the right portion of the airport, identifies size of plane, that sort of thing. And we'll show some of that power that the Ingress has. So to touch on what you said around services, and I'll show you what this looks like in a second. Probably the first thing you did after you deployed that first replica set is you deployed a service. And services are pretty cool because they're a stateful access point for logical set of pods, right? Pods in Kubernetes are ideally stateless. They come and they go. They scale up, they scale down. So I need a sort of consistent way to get at that service from outside the cluster. And there's a number of types of services. Node port is one that people are familiar with. Kind of the easiest one is a type of load balancer when you create that service. And depending on the environment you're in a Google Cloud environment, that's actually going to create a layer 4 load balancer for you, set up firewall rules, and do a lot of great automated work, all from just this one tag in your manifest. Where Ingress is great is, like I said, load balancing along multiple services, giving your services externally reachable URLs. You can terminate SSL on ingresses. You can do virtual routing. So what does this look like in the environment? On the left, like you were saying, Jonathan, the service is the way that you expose a set of pods. A service defines, hey, all these pods are the same app. We've used this label to target them. And we've kind of either punched some holes via node port or created a load balancer. And this is a great, quick way to expose an application out externally.
Wow. So it sounds like Ingress pretty much adds almost additional, based on this diagram here, it's adding additional capability to the service, right? Like
exactly. Not just, and what we're doing is we have a lot more intelligence in a single object that, whereas a service will load balance across pods and give you that stateful access point, and Ingress will actually load balance amongst services. So you can have a single IP address or even a single port. Let's say I have a ton of HTTP traffic. Send that in my Ingress, and then my Ingress can route it to the appropriate service based on URL, based on the host name. And so it provides a lot more power for your routing.
So Drew, would I only need one Ingress controller then, or when is the case that I would need multiple?
Yeah, great question. So, and we'll actually touch on the difference between an Ingress controller and an Ingress. And I think this was one of the things that tripped me up when I was deploying my first Ingress and reading through that documentation. So I'll actually answer that question first, and then answer your question.
Yeah, it sounds like,
when would I need
sounds
multiple
like a good place to start. Yeah.
Yeah. So the biggest thing that I want you to take away with Ingresses is the difference between the Ingress controller, the load balancer, and the Ingress object itself. And this is kind of a tricky one, a little bit different from service type load balancer, where when you deploy an Ingress object, and we're looking at that right here, you can kind of see I'm routing traffic to host foo.bar, and I've got different paths, path foo, on different ports potentially. Well, I'll talk about what that routing is. When you create an Ingress, this Ingress object, you're simply posting this set of rules to the Kubernetes API, and then this Ingress object just lives in the Kubernetes cluster. So nothing's really been done yet. It's sort of this just logical object. Where the real magic happens is when you have an Ingress controller looking at the different Ingress objects and trying to satisfy what they are stating they want, right? They're saying, hey, here's kind of the set of routing that I want. Can you do this for me? And the controller will actively pull and look for objects to satisfy. So in the case of a GCP environment, by default, we have an Ingress controller that runs on the master node. It will pull for your Ingress objects, and when it sees one, it'll actually go and program the layer 7 global load balancer for you. If you're in, say, a non-GCP environment, you might install yourself an Ingress controller running on NGINX. And that'll do the same thing. Once it's running in your cluster, either on every node via a daemon set or on a couple nodes, that controller will continue to look for Ingress objects to program itself.
Interesting.
So that's
yeah. So it sounds like these are kind of two peas in a pod. You kind of have to have one to have the other. Is that the right thing? Or you can have Ingress object without an Ingress controller, but it won't do anything.
Exactly, and by default, an Ingress controller will, in a Google Cloud environment, that just gets installed by default. In a vanilla Kubernetes, you're going to have to install the Ingress controller yourself. You're absolutely right.
I see. I guess the benefit with the container engine then is when you set up your Ingress objects, you have a default Ingress controller that is already set up and instantiated for you. Whereas if you were running, let's say, the open source Kubernetes, you probably have to spin up like an NGINX or some kind of load balancer or whatever service that you need to connect and pull from Ingress objects.
Yeah, it's set up automatically, and I've got a cluster I just spun up a couple minutes ago that we'll see. I'll show you how quickly you can get these services exposed. It's not terribly hard to set up that NGINX controller. That's fairly well documented. What you still need though is some sort of external load balancing mechanism to either spray your traffic across the different nodes in the cluster, or maybe even more intelligently, spray that, know where the pods are currently existing and send traffic to those given nodes. The Ingress controller will take it from there and do your URL-based routing, termination, etc. The other thing to note, and I'll touch on this a little bit later, is that if you are in a GCP environment, because this Ingress controller for the cloud load balancer is on by default, if you were to install your own Ingress controller, it's important with this Ingress object to annotate which one you want to satisfy it. Because remember, this is more of that these controllers are pulling for Ingress objects, and when they find one, they're going to try and satisfy it, whether that's an NGINX server programming itself, or a replica set program itself, or whether that's the cloud load balancer actually programming that layer 7 load balancer for you. And I'll show you how to do that. To answer your question, Deanna, when would you want different Ingress controllers? So it's in the cloud environment, you'd want a different Ingress object. You'd want a different object for essentially each IP address. And I'll touch a little bit on the cloud load balancer, how you can have a single IP address all around the world that's giving you global load balancing, it's giving you redundancy. We're not using like DNS load balancing. And you can have that single IP address serve many different host names, many different services, many different backends. Let's say you have sort of distinct applications that you really don't want to be using the same IP address, or you want to version them totally differently. You might create a separate Ingress object, which would then end up in a separate global load balancer for that service. Does that answer your question?
Yeah, thank you.
So I think it's easier to kind of jump in and create an Ingress and show you the difference between a service and an Ingress, and just how easy it is to have a globally load balanced kind of URL routed service. So
yes, demo is my favorite part of these. I want to see a demo.
So I've got a 3-node cluster that I just spun up a few minutes ago, running in East 1B, and
where you're from?
Which is closest.
So this is a 3-node Google Container Engine Kubernetes cluster.
Mm-hmm. So let's see, I've got the default service running, and since it's a fresh install, it just took a couple minutes to spin up the entire cluster. I've got my typical, this is the sort of default containers running in the kube system namespace. What we don't actually see is that global cloud load balancer Ingress controller, because that's running on the master node. So that's managed for you. That's, there's an SLA around that. So we don't actually see the Ingress controller in our view. If you were to use an NGINX controller, you would see that, and you would actually create that replica set yourself. So it was pretty cool to set that up in your second go at Ingresses. So I've got essentially an empty cluster. So the first thing I'm going to do is create a service. So I've got a couple YAMLs here. I'm not going to focus too much on the services themselves, just a dummy HTTP app, and later a dummy Apache server. So I'll go ahead and create my HTTP service. Those pods are coming up pretty quick, right? Now, this by default, this is a type node port service. So there's no load balancer associated with it. I can get at the service actually. by hitting sort of this random port. If you've looked at node ports, there's sort of the stopgap measure when I don't have a load balancer strategy. I can just throw traffic at this port on any node in the cluster and it'll get to the service. So it's not elegant, but it gets the job done. So one of the first things I'll do just to show that type load balancer, there's this handy little command called patch. And this will strategically merge manifests with an existing, an existing service. So pretty cool. I can kind of annotate things as they're running. I just changed this from node port to load balancer. This basic HTTP service. You can see that external IP is pending. So for those of you that have created a service type load balancer, you'll know that what Kubernetes running in Google Cloud will do is it will call the Google Cloud API and create a load balancer for you. It'll program some firewall rules and will pretty quickly expose your service in a redundant way.
Hey, Drew, can you describe the patch functionality again?
Yeah, it's a pretty cool functionality. It's going to strategically merge what I've added here so that, for example, this HTTP service, I said it was type node port. Type node port right here, right? And so I've kind of overwritten that on an existing service, and then Kubernetes will say, hey, I've got a new state I have to satisfy. Let's make it happen. So I see here, just 30 seconds later, I get an IP address back.
So instead of changing the YAML, you can pretty much use a command line to switch out one of the
parameters. It's pretty slick, right?
Yeah, I didn't even know about that.
That I learned from the Ingress documentation, believe it or not. So just to kind of review, we've got this layer 4 load balancer. It was programmed. Firewall rules good to go, and I can access my service anywhere, which is great. So let's up the game a little bit and go back to, send this back to node port. That's patched. Let me deploy my Apache service just so I can show I've got a couple different services running. Come on, get. I've got an NGINX-based service, HTTP, and an Apache-based service. Nothing fancy, just to differentiate which backend is serving my traffic. Both of these are node port. So let's not do layer 4 load balancing. Let's do layer 7 load balancing and put some pretty cool logic in front of my application. So this is the Ingress object I'm about to post, and this is where the magic really happens. So it's a type Ingress, and I've named it app GCE load balancer. Now this is pretty key. If you're out of the box deploying Ingresses to GKE, it's just going to use the global layer 7 load balancer. If you're ever going to use an NGINX Ingress in conjunction, you'll want to use an annotation. And an annotation is a way of specifying, it's not a comment, it's not for kind of viewing or searching, it's to actually tell Kubernetes how to do this. And in this case, I'm telling Kubernetes, this is an Ingress object, and I only want it to be served by the Google Cloud Ingress controller. So this is key if I were to later deploy an NGINX Ingress controller in the same cluster. If I didn't have this, the NGINX Ingress controller would also try to program itself to satisfy these rules. In this case, I kind of know that I'm going to have NGINX in the future, so I tell the cloud, hey, just use the Google load balancer here. In the spec, and this is where the power is at, I say for a default backend, that's the first one, target this service on this port. So any traffic that just doesn't match any of my rules, throw it at this backend service. And this could be like a kind of a Bitbucket service, 404, just in case you don't want to be serving traffic that somehow gets the load balancer without a host or a path. In this case, I'm actually going to use just my HTTP curl service as default on that NGINX server. Then when I get into the rules, this is where you can route based on host name, virtual host name. In this case, anything to the foo.bar host, I will take a further look at and look at the path of the traffic. So anything to foo.bar slash, hey, send, or that could be /star even, send that to this HTTP service on this port. Any traffic hitting this load balancer to foo.bar/video, this could be like /video star, send it to a different service. So this is where I can use a single load balancer and have a bunch of different services serving the traffic there. I don't need an IP address for every little piece of my application. This is super powerful when you've got a microservices architecture and a lot of them are externally exposed.
Yeah, this is great. So this YAML file that you're editing, is this an object?
Yeah, this is the Ingress object that's going to get posted. So let's go ahead and create that. This is the Ingress object, and then we'll see a little bit of a delay and let me show you right now what's happening under the hood. This is going to be a little bit slower than the layer 4 load balancer, but I'll do my handy watch commands. I really like these watch commands where you can see what Kubernetes is doing for you. So just like this Ingress object, we see here's the name, default namespace, default backend. This is where I'm sending kind of all unmatched traffic. And you can see how Kubernetes matched that HTTP service to my actual pod IPs and the port they're listening on. So right away, Kubernetes has matched my service to the backend infrastructure, which is the beauty of using service names. And we can also see the rules. Anything to this host at this path, send it to that service. Here's the pods. Here's the endpoints I can send that traffic. Same thing with /video. Send it to these endpoints. So we see the logic match between the two of them. What's going to take a little bit is programming the Google Cloud Layer 7 load balancer. So you can see, we'll see this pop up pretty quickly. So it just created a bunch of stuff for us in the Google Cloud load balancer. And this could be quite a lot of work to do yourself. See here, my layer 7 load balancer. And you can see it's recreated all that logic. It's giving me a single IP address and port that's globally accessible. And it's used this external load balancer to route all this host-based and URL-based traffic. So it's created 2 backend services for me. It's created the one on port 30,301. This is the NGINX backend service. And here's 30,302, the Apache backend service. And you can kind of trace, it's obviously a little bit easier to see right now in the Ingress object in Kubernetes, but you can see how it's referencing these different backends within the load balancer. Now, the one other thing is that these health checks will take a few minutes to kind of determine that I can reach services in the cluster. And the layer 4 load balancer wasn't actually doing health checks, whereas this layer 7 load balancer will.
Yeah. So do you need to have a service for Ingress?
I am almost positive you do, so that we can track which pods to service. I'd have to double check that one though. At the end of the day, Kubernetes needs to know which endpoints to hit. So there are a couple exceptions where you can expose like a native port on a node, not node port, but host port, and kind of go back to traditional Docker networking. That you might be able to do something like that with this, but definitely advise to use services, because that's one of the key pieces that solves the traditional Docker networking pain points. And we can see here my health checks have come up. 1838. And let's see, you want to call out backend. One thing that I do want to call out is this instance group. One of the things Kubernetes will do for you is create an unmanaged instance group, which then you can target with Google Cloud load balancers. Internal, layer 4, external, and layer 7 load balancers. Kubernetes will keep this instance group up to date for you as you add and subtract nodes from the cluster. So let's see if we can get at this. So we've got our IP address now. All right, so sometimes it takes a couple minutes for the global load balancer to converge. In this case, it's saying we haven't matched the host. But I'm actually routing, you can see I'm expecting a host name. So let's see if that changes anything here. All right, so we're going to give it a couple more minutes to converge.
Nice. Oh, 404 not found. Yeah, I think the one really nice thing about our load balancer is that it's only like one IP, right? I mean, it's like globally available. It really is a global load balancer.
Yeah, and the reason this one takes a little bit longer than the layer 4 is that this IP address is advertised out of, I think, 120 points of presence. And what's happening is this is programming all of those 120 points of presence to forward your traffic right straight back over the Google backbone to this Kubernetes cluster. Sometimes they take a little bit longer than others to converge. What you get at the end of the day, though, is it's pretty clear. You can route to not just one or two services, but I can over time continually add. Let's say I have a new service, and I want to do images. This could be my maybe I'm serving them off of CDN, but maybe they're dynamically created. I have an image service, and you can continually update this Ingress object. That Ingress controller will pick up the changes and program the load balancer for you.
You know what this reminds me of? It reminds me of like an API gateway, almost being able to, depending on the URL route, push your traffic towards different microservices. Maybe this is why Kubernetes and Google Container Engine is really suited for microservices, is because you get this functionality that allows you to send traffic to different services that are actually different apps, inside of your cluster. So I used to work a little bit with API gateways, and this is looks like exactly what it's doing.
Yeah, and so you're absolutely right. So now that it's come up and converged, you can see that if I hit I'm kind of spoofing that I'm actually hitting a real IP address, but I'm just adding the host header. You can see if I just hit the generic host, I get matched by this is my NGINX server. If I do a single backslash, you can see I have a rule there to hit NGINX. But you can see if I do /video, I'm actually hitting the Apache server. So you see the error is totally different.
Yeah.
So you can see just with that Ingress object, I'm routing across two backends. This could be many, many, many different backends.
This is super cool.
Yeah. So just a couple closing thoughts. So really, hopefully this shows you how to get started with the Ingress object. A couple closing thoughts is if you want to use this fancy URL-based routing internally, so internally accessible to your Google Cloud environment, you would want to go ahead and use that NGINX Ingress controller. Pretty easy to install yourself. Just important to remember to annotate your Ingress objects. So this would be, instead of GCE, would be NGINX. But that gives you an internally routed, fully blown URL routing system. You can bake in SSL, that sort of thing, to these Ingress controllers. I'm trying to think what else. And yeah, federation. One last thing I'll say is if you're using federation, not the Ingress object today is great for a single cluster environment with regards to the Google Cloud Load Balancer. If you're going to use federated clusters today, I would recommend programming the load balancer yourself. Not too hard to do. You can see here that you essentially just input these objects yourself. You'd have to maintain them and program directly to the gCloud API as you added new services. So the Ingress object won't handle that for you. In the future, definitely expect something like that to change. One other thing that will change and will be pretty cool is today, our load balancers are, for the most part, they're spraying traffic across the whole host. So if I see get services, these are all node ports. So the load balancer is kind of just going to round robin across the actual Kubernetes nodes. In the future, expect the Google Cloud Load Balancers to know where your actual pods are living within the cluster. This is great once your cluster is in the hundreds of nodes and you've got a service that's only a few pods large. You can send traffic directly to the right node. So that's some of the stuff coming down the pipeline.
That's really interesting. I know we got a couple minutes left. So how are your customers using Ingress? I mean, obviously you've done all this work because you've had, some large customers trying to use this. What are their use cases?
They love Kubernetes. They love the idea of just being able to program an entire application infrastructure in these YAMLs and build these really powerful manifests. And they love the fact that once they post an Ingress object to the Kubernetes API, Kubernetes will program all the stuff that needs to happen in Google Cloud. So not just the load balancer, but it'll open up the appropriate firewall rules. It will open up firewall rules for health checks. It does a lot of this stuff that's easy to get tripped up on that first couple times around, and it just does it automatically. As you add services and pull out services, add ports, pull out ports, it just is handled for you. So the use case is, hey, I've got a lot of different services that I'm exposing, and I just don't want to have to worry about wrangling with infrastructure. It's really easy to version this kind of thing and edit in Ingress as you go along.
Right. I know I was working with a customer looking at Ingress. I mean, being able to use Ingress with Google Cloud Platform is really useful because we do have that managed global load balancer. I mean, we do the health checks. I mean, we manage that load balancer for you. And I mean, ultimately, our customers don't want to be in the business of managing load balancers, right? They want to make sure that their application is highly available, well performing, and the user experience is really good. And so that's, from my standpoint, what my customers like to see.
No, absolutely.
Yeah. So this is good. And I mean, I'm interested in, everyone on the live chat, if you can talk about your use of Federation. I know Federation's changing quite a bit. I mean, there's a lot of activity there. So if there's some interesting use cases, definitely say something on the live chat. But we're at bottom of the hour, and I don't know, Deanna, do you have anything else to say before we part ways?
Yeah, I was going to ask, Drew, you'd mentioned some of the stuff that's coming down the pipe for Kubernetes. Where can I go to learn more about what's coming out in future releases?
Definitely take a look at what's happening on GitHub. I think call up your your Google Cloud engineer. Certainly has a lot of information on what's going on there. And if you're not involved in the Kubernetes community, definitely encourage you to do so. The development pace is tremendously rapid. I don't know if the second birthday Kubernetes just happened or is about to happen. It's incredible how much buzz and development and just how many systems are already built in Kubernetes for the service only being 2 years old.
Yeah,
Awesome.
It's pretty incredible how fast this has grown. So I know if people have questions, Drew, I'll put your phone number on the community forum. If that's okay.
Absolutely.
Phone address, the whole thing.
Well, you're on my number one hot list, so I'll call you for any questions.
Yeah.
But thank you for your time, Drew. Thank you, Deanna, and for everyone listening. Thank you so much for joining us. And email us gcponlinemeetup@gmail.com. We're always looking for new topics. And if you have a story to share, we're super happy to host you as well. I just want to emphasize this is supposed to be a community, event, and this is not just us Googlers sharing about GCP. We'd love for you to share with us how you're using it as well. So thank you again, and have a great week, everybody.